Good evening, everyone. Thank you to each and every one of you for being here with us today. Uh, we are very pleased to be able to welcome everyone to the Azure PayDay, organized by Microsoft Learn Student Chapter, Bharati Vidyapeeth College of Engineering. Sarthak?
I would like to welcome Dr. Narina Thakur ma'am with us over here. She's the Dean of Research and Development at Bharati Vidyapeeth College of Engineering, and she's a Chief Coordinator who has helped us to organize this event. She has always been very enthusiastic about sharing her knowledge of technology with us and has always encouraged us to pursue technology with sustainability and novelty in mind. Thank you for guiding us and helping us with this event, ma'am. Do you have a few words for us?
Yeah. Distinguished speakers, participants, and dear students. Um, I have, my name is Narina Thakur, and I'm Dean Research and Development at Bharati Vidyapeeth College of Engineering. And I'm here today, to give a welcome address to all of you. It's a glorious moment to extend my warm wishes on behalf of the Microsoft Learn Student Chapter, BVP. I want to convey my heartfelt gratitude to Mr. Siddharth Khanna, Azure software developer, and Mr. Bruno, lead innovation at Avande, Canada, for accepting the invitation and presiding on this Azure PyDay at as a part of our Microsoft Learn Student Chapter BVP effiGO 2021. I'm glad and thankful to both the distinguished speakers who spared time from their busy schedule to grace the occasion. Wish all the participants a happy learning. Thank you, everyone.
And now I would like to welcome our today's guest, Mr. Siddharth Khanna and Mr. Bruno. Firstly, I would like to extend a very warm welcome to Mr. Siddharth Khanna. He has been working in Microsoft Azure for the last 1.5 years and has 8 plus years in building scalable architectures. Before joining Microsoft, he worked for 4 years at Naukri.com. And that's not all. Apart from tech, he is a fitness, food, and travel enthusiast. Now, Mr. Siddharth Khanna will be addressing all of us, and please feel free to ask all of your doubts during the event in the chat box.
Hi, everyone. Thank you, Ankita, for this introduction, as well as thank you, Narayana ma'am, for inviting me to have a word with all of you. It's always good to give back to the community I came from, and it's always a pleasure to be invited to such an events where students can learn and they can grow in their fields. So yeah, Ankita, as you rightly mentioned, yeah, I'm working with Microsoft for the last 1.5 years, and I am working with their Azure team. So basically, we are using Azure, which we call as the world's computer or world's brain, and we are using Azure for hosting our services for a lot of. So whenever you basically our service is more inclined towards activating your Windows system. So whenever you are using any Windows or you are activating any Windows operating system, you are buying a new laptop, or probably you are activating a new Microsoft Office or Xbox or anything, that whole transaction of activation and validation comes to us. And we are the ones, when you enter the keys of 5 by 5, which is given to you by the vendor or our online sites, that key comes to us and we activate that key. So I am working in that team in Microsoft. Yeah, before that I've worked with Naukri.com. And I think Lenskart before, and Inox Apps also before. So I've an experience of around 8+ years with 4 companies, and so I basically I'll just go through as a theoretical model of what is cloud computing, and I mean, in very layman terms, I'll try to explain how cloud computing are solving the problems which were earlier there, and which probably still exist with few of the systems in the world which have not moved to cloud computing. Uh, so I mean, I can start with telling you a very basic example. So what happens when you order a pizza from Domino's, or what happens when you order your favorite hamburger from McDonald's? So just think of it as Domino's spending time in ordering new Windows operating system and not making your pizzas, right? I mean, this is not their main frame. You know, managing the servers, managing on which their application runs, on which their site runs, is not their main business. Their main business is to give pizza. Okay, and you know that's a very important business. And so, if someday McDonald's or Domino's will start, you know, will start patching their latest Windows or Linux or Mac OS, whichever server they're managing, or probably installing a new version to their systems, saving themselves from the threats that are growing nowadays. So what will happen is you will not get your pizza delivered in 30 minutes. That's for sure. Okay, and they are actually doing majors and minors. So their major is to deliver a pizza, but then now they're doing a major and minors, that is managing their online site, managing their offline sites, managing everything they are on, which helps you to order a pizza. That is not their main business. So here comes cloud computing. Cloud computing helps you or helps them or any company come to the cloud, and they say that we will manage your system, I mean your systems, and you focus on the core part of your business. Don't focus on an IT team which will be managing your servers, a coding, probably a developers team which will be coding for you, a testing team which will be testing. So, I mean, these teams will still be there, the coding and the testing, but don't focus on the deployments part. We will handle the servers for you. We will make sure no threats come. We will make sure your as the scale, or even if you know on the New Year nights or on the Christmas, if the scale of ordering pizzas increase, your site does not go down. So we have seen that government sites usually go down because most of them are not on cloud and are still on their, you know, the old servers. So these things, any cloud platform solves, which range from basically Amazon AWS, which also range from Microsoft Azure. We also have Google Cloud and with us. So these things are the perfect example. So I think one of the perfect example is also bank. Bank systems earlier were on their native server. So when you go to a bank, probably for an example, any bank, you might have heard from them that servers are down. They can come back again. Okay, so this is the kind of problems you face when you do majors and minors, and when the people handle everything, when the specific people handle everything, and the things are not on cloud. So these are the things that happen. If that is on cloud, the servers cannot go down, right? Because if Microsoft Azure servers or Google Cloud servers or Amazon AWS goes down, then lakhs of people will be impacted. Not even the bank, but everyone. So so cloud computing provides you with everything: the cloud servers, the databases, the networks, the intelligence, the software, and moreover as a pay-as-you-use model. So you pay for what you use. So that's the whole bunch of things that cloud provides, and you don't manage anything. Neither servers you have, nor databases, not networking, nor intelligence, and not the softwares. Everything the cloud manages by itself. Okay, so probably a layman example of something is uh, why do companies like McDonald's or Domino's or Apple want to take this, I mean headache. I mean, their business is not that, right? Their business is not into coming to servers and managing them. So this is where Azure or AWS comes in. And currently, I think going by the facts, Amazon AWS is the largest share holder of cloud computing. But in terms of revenue, what I have heard is Microsoft Azure has surpassed Amazon AWS this year in terms of revenue, but still, as per the number of players that are in the market, Amazon still holds a very significant number of companies or number of clients that still deploy on Amazon. So I can say that yes, Amazon AWS is the market leader, and Azure is very much close to it, and maybe someday soon will beat it. So this is happening. Google Cloud is still ramping up again. So these things actually make life easier for a company or for a client. Okay, any doubts? Probably I'll give a minute here to if anyone has any doubts. Everyone understood everything? That's great. Okay.
Yeah, it was pretty much clear.
Okay, that's good to know. Okay, so coming to Microsoft Azure, coming back to Microsoft Azure has three main offerings, and then probably now we are going in little insights. I won't drill down to the to very elementary level, but at a very high level, we have three things that make cloud usable to their clients. One is definitely the software as a service that we call SaaS, and that is what we all use. The Google Sheets is I think the perfect example of a SaaS, where I go to my browser, I log into Google, I use their sheets, and I think Microsoft also provides these things in the terms of Microsoft OneNote. So this is one of the offerings that are given by that are given by SaaS, and the other one is IaaS. So I'm not sure whether anyone has heard about IaaS or not, but that's infrastructure as a service. What do you mean by infrastructure as a service is they will give you a server, manage yourself, but server is not with you. So when you go to Nehru Place in probably Delhi, if someone is in Delhi, and I think most of them have heard about Nehru Place. So when you go to Nehru Place, earlier used to say, I want a server of a configuration of this operating system, of this i3, of this graphic card, of this number of CPU cycles per minute. So these all things you tell. So similarly, in IaaS, when you go to Microsoft Azure or Amazon AWS, you tell them what you want. You tell them, I want a server with an i3 processor with a Windows operating system, with an NVIDIA graphic card, and having 2 gigahertz cycles per second. And the Microsoft Azure or AWS or Google Cloud makes that server for you. And it's a virtual server for you. There's nothing physical in that. And you can use that server. All you need is a good internet connection, which I think is slowly everyone is will be having, and also few of us are still having a good internet connection in India as well. So all you need is a good internet connection, and they will manage everything. So they will give you a plain server, and they will also give you an option. So it's basically like your physical hardware. You don't have the machine. That's it. That's called IaaS. Now, even IaaS is a challenge sometimes. Why? Because you need to tell what operating system you are using. Is it a Windows? It's a Linux? So consider itself as if I am a student like you and I want to open a site. I want a site to be up and running with basic requirements. I don't know exactly which OS I should use. I don't know, how to do a software upgrade, or probably I have very less inkling about it or idea about it. So what to do for those clients? Probably a dance institute is a perfect example. A dance institute or dance where there is a dance teacher and student. A dance teacher just wants that my site is up and running and it should be reliable enough so that it doesn't get down. Has a reliability of 99% or 99.99%. So this is where Microsoft Azure developed PaaS, and PaaS is platform as a service. Anyone has a question?
I think it was my background voice or something.
Okay, no problem. So hence Microsoft developed PaaS. PaaS is platform as a service. Okay, so what it does give you is, now you don't maintain a server. Now you don't maintain an OS. Now you don't maintain a software upgrade. Now you don't maintain anything and focus on your development. Okay, just focus on the application you have. Leave the rest to Microsoft. That's I think the technology that PaaS is offering, and a lot of clients are using PaaS in Microsoft. And the perfect example is what we call as app service. in technical terms in a PaaS, and there are also other things like Azure Kubernetes is there, and other technologies, Fabric, Azure Fabric, Service Fabric is there. So there are a lot of technologies when you comes to PaaS, and PaaS is one click. You click that I want this, the server is ready, everything's ready, you deploy your application, and then you're good to go. So this is what PaaS offers. PaaS has a very high level of scalability. They give you very scalable kind of architecture where if your request increases tomorrow, so supposingly I'm a very small dance, I teach dance. I teach 10 students. Tomorrow I am on a video call with students in an online world, and my students increased many folds to 100 in a month. What will I do? I'll be bringing servers more, everything more, and then I'll be teaching dance. But I'm a dancer. I'm not a software developer. I'm not a server manager or database manager. Nothing. I'm just a dance teacher. Okay. What I will do is I'll tell Microsoft to increase to 100. Or probably even better is Microsoft. If someone has probably checked that option, Microsoft, on the basis of scaling, or if the 100 users are there, it will itself increase the servers in the background, and the client won't even notice that the servers are increased. So this is the kind of technology that is currently in the market in terms of cloud computing, and these three things are used interchangeably: SaaS, IaaS, and PaaS. All three are used. All of them has benefits. All of them has cons as well, where IaaS probably provides enough flexibility to you to choose an operating system and everything inside that. So that is also useful in some circumstances where people like to have a very granular level of control. Supposingly in your laptop you like to have, I will have a something like 2 GB RAM only. I won't have 4 GB RAM, or something like I will have a antivirus of a specific company. I won't have an antivirus of anyone. So there comes probably IaaS, and a lot of players in the market are also using IaaS, and a lot of players are also using PaaS. So it's a trade-off that you have to make, and I think that trade-off is clearly listed for what fits you best. Okay, I hope till here we are able to get what is Microsoft Azure. It is also known as Windows Azure previously. So I think now maybe I think some of you have a rough idea about how will you work going forward? How will you work? If you have to choose something, how will you choose? If you have to start reading Microsoft Azure, how will you read, and what is the starting point? So Microsoft Azure is very huge. Even when I came and learned it was quite a challenge for me as well. So it's a huge, cloud computing is huge. So having those idea about from where to start is very important, and especially as freshers, where where you will be tested in a company not on the basis of only the technical skills you have, but also the learning capability you have. So don't just go to a company and show your technical skills. It's more about how you learn. That is getting tested at the background whenever you interview a company. So it's more about how you solve a problem. So you have to have a depth and breadth of knowledge if about cloud computing or anything. At least you should know the rough idea of how things work. So you are one should be a good learner. One should be a good challenge. Something solve puzzles, solve challenges, and not only the technical skills that matter. Okay, you'll be through it. All the technical skills once you join, or once you come, or once you work for anyone, or in the college, you will gain that technical skills. But don't focus on that much. This is not what most of the people think as freshers, but this is not what happens in the terms of the interview. So this is what is cloud computing. I think any doubt on this, or anyone wants to ask anything extra on what probably Microsoft? Yeah, go ahead.
Sir, what is the serverless code architecture?
Sorry, your voice is breaking.
Sir, am I audible now, sir?
Okay. Yeah. Now you're audible a little bit. It is coming a little bit noise, but yeah.
Sure. Sir, the Azure offers us 1 million requests per month. That is the processing of the events with a serverless code architecture.
Okay,
Sir,
okay.
can you explain the serverless code architecture?
Okay, serverless. Okay. So serverless code architecture is similar to what I told. It's as the name implies, you don't have the server. Like the serverless is you don't have the server, so that's it. That's what I explained as well as the previously also. It's basically a way to build and run applications without having to manage infrastructure. Your application to you feels like it's running somewhere in the virtual world, somewhere in Europe, somewhere in US, somewhere in Australia, somewhere in South America, somewhere in Canada. So you still think that your service is running somewhere, but it is invisible to the client. It is invisible to you. You can't see what is the server, where is the server. You will know that that the server is in Europe, but you won't know that which server is mine out of all these things. So you don't know that. So your application still runs its server, but all the server management is done by Microsoft Azure. You no longer have to scale and maintain servers. Scaling is done automatically. You don't have to scale your servers or database, for example, or some type of system, storage systems, Redis, cache. You don't have to worry about that. All you know is your code is running somewhere in the world, and that is what is the concept of cloud. So, and your second question was how one is handling millions of requests. That is all scaling. Scaling and optimizations are the two things that how any site or any application handles millions of requests, and that scaling is also more or less taken care by the cloud computing. So you don't need to worry about how many requests come, how many get served, how many alerts you get, how many failures are there. Everything is taken care by the Azure.
So is this system centralized or is it like distributed? Like suppose you said London and Australia. So if I'm running a code on a server, can my code be like in London as well as in Australia? Both the servers working together? Or is it centralized? Like my entire code is running at one place?
Okay. No, your code will not be running at your place. I mean, at one place. It depends again on how you want to structure your deployments. You can have something at one place, but then if that goes down, you don't have failover. So everything is failure prone. Nothing in the world is there which where we can say that this is 100% reliable. Every reliability is 99.99%. Like that, like the ad of Dettol, which kill 99.99% germs. Okay, we still have viruses here. So no one has 100% reliability. So to basically have that reliability, you basically distribute your servers to different regions. So what happens if tomorrow Europe has a lightning streak? All the servers will go down in the Europe, and your site or your application will again go down, which will create a negative impact for you and your clients. So this is where primary and secondary concepts come. So you will deploy something called primary at a place in Europe. You will have a secondary in Australia. So or you can have a secondary in America as well. So whenever your Europe version goes down, secondary takes place, and this taking place or switching over, what we call, these also are taken care of by Microsoft Azure only if specific settings have been enabled. So you still have the option to enable them or disable them. And if they are enabled, Microsoft Azure will itself route your request to the nearest center or the secondary data center where you have probably told Azure that you will be hosting your server at the secondary region here. So that will automatically be taken care of. And it's a decentralized system.
Sir?
Yeah.
Sir, what about the security?
Okay. So security also Microsoft handles for you. Okay, so Microsoft will have a lot of things for your servers to be secure. What are these things is very wide, but then you don't need to worry anything about, someone hacks your system or someone. I mean, hacking happens. Even with the world's greatest securities, hacking happens. but then it's not easy. No one can just come up and say that I can hack a Microsoft Azure, or I can just hack their system. It's not that easy to hack, and yeah, that is also taken care of by Microsoft only.
We have a question in the chat box as well. Siddharth, if you'll just see it.
Sure. Can you read that question aloud so that everyone can?
Yeah. Lakshya has asked, I'm just curious, on the cloud computing server, we can actually download and run any software which are sometimes not possible for my old machine. For example, Final Cut Pro.
Okay, what is the question here?
I'm trying to figure that out as well. So Lakshya, if you'll just ask yourself. I think that he's questioning about how he can, download other softwares as well.
Okay. Yeah, that's a good question. So basically, this is where IaaS comes. So in PaaS, you don't have this flexibility. In IaaS, which I discussed a few minutes back, this gives you a flexibility to log into the server. You log into the server, you will have a username, password, or you will have an elevation through which it will test your credentials, and it will only allow you to elevate and probably what we call as a VM, virtual machines. You will have a VM, you will log into that VM, you will go to the internet, it will have an access to internet, it will have access to everything you want it to access. So internet also is there, you just go to the internet, you download that. Moreover, if you don't want something from the internet you have on the physical copy, just drag and drop it to the virtual machine. It will itself copy to that machine and you can run it from that machine easily. Does that answer your question, Lakshya?
Sir?
Yes, it answers my doubt. Thanks a lot.
Okay.
Sir? Sir, so what if, sir, can I host a heavy graphic rendering application on the Azure?
Yes, you can. You have to select a graphic card which renders your application. There is an option to provide graphic card and the number and the amount of RAM that you want. Probably a 12 GB, 64 GB. Azure has still, I think, a TB of RAMs. So don't worry. I mean, it is handling a lot of load in the world, which probably something at a scale of Netflix.
Sir, can I play like a video game? I can just server and on my screen and control it from here.
Okay, then it depends on your internet connection also, because server can do everything you tell it to do, but then it will tell you. I mean, those are very fast. So the data that is coming to you will be too much, and that depends on the connection that you have. If you have a very reliable connection and very good connection, you will be able to.
Okay, sir.
Are you planning to download Counter-Strike on the virtual machine?
Sir, I was thinking about like Shadow of Tomb Raider or Forza.
Okay. Yeah, you can play that.
So even I had one question regarding cloud gaming. So it's a very up and coming concept right now. For example, NVIDIA provides one, and etc. You can game on your mobile and it runs somewhere else. So in that case, how do you manage latency? For example, in gaming, you need to be very real time. So latency should be an issue in that case.
Yes, correct. So that's where that's what I discussed, that you need to have a very reliable internet connection. Basically, what happens is gameplay, I think, it will stream over the internet back to you. It will allow you to play the latest games or probably on any device, but then you will need to have a reliable internet connection, a powerful GPU that we tell you need to have that kind of interactivity. Also, there is a concept of, I mean, that's a little more to discuss, but there's a concept of threading that happens in gaming, and those threads handle those things for you. But I think that will be too much for you. But basically, you will need to have a very good connection.
So I was just curious. So for the people who are working with like graphical neural networks, it's really like new, and it requires a lot of again, a lot of computational power, right? So sometimes if you like run basic graphical networks, Google Colab just crashes down, it just gives up, stating that I cannot. So since that, okay, how are Azure systems doing it better jobs? Like I know that Azure notebooks used to were available until January last year, and now they are like discontinued product. So when we deploy several graphical neural network models or very complex machine learning or deep learning models, how does Azure capture that and provides scales properly and does not?
Okay. So Azure has something called Cosmos at the backend running. Cosmos is a NoSQL database. NoSQL is a no structured database. I think that's a pretty new technology, and that's a very good question. And I think a neural network, the brainstorm is very, I mean, the Microsoft Azure Machine Learning Studio, what we call as ML Studio also. So, I mean, that Cosmos does things for you. And Cosmos is a very highly reliable, highly distributed, highly available system in the world. And all the things that happen at the back end, Cosmos takes care of that for you. Does that answer your question?
Yeah, sure thing. So it's like a NoSQL database, but how it is covering all the aspects of it? Like
Okay. So you are basically asking how is it storing all the data, because in machine learning storage learning. Okay.
Yeah.
So it's a very wide question and a very wide answer I will have to give for this. Basically, how is it performing is it's running some jobs at the backend for you, and you have to configure when the jobs run, and how the time it will take will depend on the configuration that you have selected for the Cosmos, for the RAM, for the processor, what configuration you have selected, and probably then you will have to align your data with the Cosmos. But Cosmos will provide you everything from distribution of data. Also, I think you will have to sometimes do like distributed computing also. So you will have to have something like Microsoft Azure distributed computing, where you will have multiple things running on multiple processors or multiple servers at the same time, and those are all giving their outputs to one particular place, and that output will be actually processed again, and then it will be stored in the Cosmos. That Cosmos final processed data will be available to you. Now, in the current technology, the time has reduced significantly, and in some of the cases, we are also observed that it's more of a real-time computation also. But then it highly depends on what configuration you select.
Just as its name, it's quite universal, Cosmos.
Correct. I mean, Cosmos is the backend for Azure, and more or less every such ML or Azure machine learning studios, everything happens on Cosmos unless you don't select something like Mongo or something. Okay. Any more doubts? Anyone has? Okay, I've taken a little more time, but I'll try to cover the rest of the part in a very very fast. And I think the last thing would be the DevOps. What is the DevOps? So DevOps is also an offering by Microsoft Azure only. Think of it as I have done my coding, I have written a game, and I want my game to run on the cloud. Okay, but before that, who will deploy it? Whether I'll pick that game and put it on the cloud, or how will I deploy it? What are the steps to deploy it? That is what is the meaning of DevOps, right? So basically, it's basically as a software as a service model. You tell that my compiled files are present here. Just deploy these compiled files to a server, and Microsoft DevOps will deploy the same to the server, and you don't have to have a deployment server for that. So every deployment needs a server. If you are running some jobs, probably I'm saying that before deploying my game, send a notification to my friends that I am deploying a new version, download it. Okay, so all the things, everything will be taken care of DevOps, Microsoft DevOps, and you will have tasks that you can add in the DevOps. So it's basically a SaaS model only, where you will have a software as a service, and that will give you a DevOps chain for developing and deploying software. It's more like you plan your work and let the deployment part be on Microsoft Azure. Build your code. I mean, the compilation of the code happens with Microsoft Azure DevOps, and it will deploy also. Moreover, there is a facilitation where what is continuous integration and continuous deployment. Probably most of you may or may not have heard this term, but then this is very popular. You must have used Git or SVN right now. You push your code to Git, it will itself be built, it will itself be deployed, and it will itself make it to the production server without you doing anything. You just need to configure that what steps you need to run when you push your code to master branch or any other branch for that matter. So this is what Azure does it for you, and Azure gives these kind of architecture, and it is platform agnostic. I think Linux, Mac OS, Windows all the three can use this Azure DevOps. I think the language support is also there. I mean, I think Node.js is there, Python is there, Java, PHP, for that matter, C# is definitely so it's not restricted to only C# language, which is of Microsoft. It is available in almost all the languages, and you will also be able to plan your work, but that will basically not be coming unless you're working in a group. You will have an option to plan your work, manage your connections. Everything related to deployment will be handled by Azure. So something is called pipelines, and if you want that some test runs, so I probably have a software which I say that 2 + 2 should be 4. Then as you build it, you want some tests to run, probably a 3-1, 1-3, 2-2, something like this. When you enter 3-2, it comes to 5 and your test fails. So this is also provided by Microsoft DevOps only. You can configure the testing and when all the tests pass, you will have a deployment. Otherwise, your deployments will fail. So you don't need to worry. You just configure once and run it. So this is the concept of DevOps in terms of cloud computing, where servers are not with you. Any doubt on both the things, whether Azure, DevOps?
No, sir, it was pretty comprehensive. It was pretty great.
Okay. So you can message me also. I'll be dropping my personal email address here. You can message me if you want. Probably drop my. Okay, you can message me here anytime you want. Anything related to anything you're not clear with, and I'll be happy to answer that on mail.
Sir, I have just one question. Like for any beginner out there who is starting to learn DevOps, is there any right path or road that you must follow like before reaching to Azure? Because there are a lot of tools out there in DevOps as well.
Okay. So can you name some tools which you are using right now or probably are planning to use?
Yeah, like I know some of them like Docker, Ansible, Kubernetes, and all of them.
Okay.
All of those. Yeah.
Okay. So you don't have to really have the knowledge of anything before you deploy on Azure. Azure is self-explanatory in a way. If you know Docker is not a deployment thing. Kubernetes is definitely a deployment strategy. But then again, that's very elementary level, and you need to have a granular control on the things, which is quite difficult when managing big sites. However, it depends then again. But with Microsoft Azure DevOps, you don't have to have a very intensive or very exhaustive knowledge before using it. So it's pretty straightforward.
Thank you, sir.
Okay, so thank you so much, sir, for clearing all our doubts and sharing this information with us. Now we have our second guest for the evening, Mr. Bruno Capuano.
I would like to extend a very warm welcome to Mr. Bruno Capuano. He leads innovation in Avenade, Canada, and also leads activities with clients to promote a culture of innovation. He was recognized by Microsoft as Microsoft's most valuable professional 13 years in a row since 2008 until today. He's an active Microsoft Technologies community participant, a writer, and a frequent speaker in national and international events. Welcome, sir.
Welcome, everyone. Thank you for inviting me. Can you hear me well? Audio is working fine?
Yes, sir.
Yes, sir.
Perfect. So I am going to share my screen. Let me know when you can see my screen. So there it is. Should be, where is Teams? There is Teams. Here we are. So the idea here, first of all, thank you very much for inviting me. It's a pleasure to be here. Also a pleasure to talk about Azure Machine Learning, one of my favorite platforms / tools. And the idea today, we have just an hour. So I usually do a big overview of the platform and then try to explain and do some live tutorials. I will go fast here. I will show you basically the parts that are not most usual. Azure Machine Learning is a full platform, and I want to basically give you a sense of what you can do. And I will try to do a step-by-step of the stuff that we can do. Sorry about the bad demos and the crappy demos and everything. I have bad jokes, and hey, I need to start with this because you are not going to laugh, but this is the moment that you can fast forward this. But let's start by the beginning. ABC of machine learning. I am not a machine learning expert. I am not a data scientist. I am a programmer, which is, I am started with the background as a programmer, and I am doing a lot of machine learning as an enthusiast. I lead projects, I do a lot of stuff. And for me, I try to keep this simple. It's ABC. We start with data, we clean our data, we organize our data, we do something with our data, and data can mean tables or can mean text files or images or whatever. And then we try to solve a problem using this data. So we pick up an algorithm or we pick up some kind of set of algorithm. We train a model with the data and the algorithm, and we start to use it. And when we use this, we try to learn from the model, we evaluate the model, we train again, we start to create a process as the previous speaker was speaking around, hey, we can do DevOps here. We can try to create some CI/CD around how we can improve this. But the ABC is data, build models, and use models. And when we started to do this, it was tricky because we have a lot of different tools. We have a lot of different elements to do this. Azure Machine Learning is kind of a single platform that allows us to do this in a single place. So I am going to use basically the hello world of machine learning, which is, hey, let's do some sentiment analysis so we can explain how to do this in Azure Machine Learning. And I will show you later how you can deploy a model and how we can do a lot of stuff. So I start with this. This is part of a big data set of Wikipedia where they have some comments that they have in the articles. They also take some moment to label these comments as toxic and not toxic comments. So basically, if someone it's good or bad comments. And the ABC is that we have these comments and we have this table. We are going to pick up these two columns and we're going to use the comment as a feature for inputs and the label as an output. We are going to create a regression model, a regression task, where we are going to try to predict if a new comment will be a toxic or not. Very simple, as I mentioned, ABC. This type of comment, it's yes or no. It's not yes or no, it's a regression, but it's going to try to predict if a comment is toxic or not. So how we do this? Start with data. First step, we pick up the table, we define features and label, and that's amazing. The only tweak here is that because we are working with text, sometimes, depending on the platform, we need to featureize this text. Everything that we are going to do in the end is going to use numbers. So we are going to featureize this to convert this text to numbers. So that's the first step. Then we pick up an algorithm. I am going to get this later, how we choose the best algorithm to train a model, and we train our model. Once we have our model, which is super simple, we can start to use this model. We can pick up and set a new comment, and we are going to have a prediction. So this is the ABC. This is the very simple stuff. You've probably seen a lot of Python, Jupyter notebooks, code that are doing this. And I am not going to do that. I am not going to show you the Python because you're going to find a lot. What I want to show you is how we can do this here in Azure Machine Learning. So in order to get to Azure Machine Learning, you need to have an Azure account. You can test this for free, and then you need to go to ml.azure.com. And the cool thing about Azure Machine Learning is that once you are here, this is kind of a single entry point to a lot of tools that we are going to use while we are working in machine learning. So an example, and again, the previous speaker, Siddharth, he talked about compute, how it's important to have compute power, how it's important to get this. So here we have in a different set of sections that we have here, we have one section. Let me start zoom it. Somehow I didn't have enabled. There it is. So here we have three main sections where we can create stuff, we can author, we can do our thinking and doing stuff. Then we have another where we can define the assets that we're going to use, data set with data, the sparring that we create, a lot of stuff. And then we have the third one where we can define what we are going to use. We are going to define here our compute power. So depending on our credit card, on our plan or whatever, we can get here and define something like an example. Let's create a new compute cluster, which is going to be kind of a virtual machine that we are going to use for to train this model. And when you create here a compute cluster, you can define, okay, what type of virtual machine I am going to create, a dedicated one or a low priority one. Let's go for dedicated. What type, CPU or GPU? Depending on the type, I will see, based on my plan, which are the available options. So if I go for CPU, in example, I can take a look here and see that hey, I have some kind of, I'm quoting smalls because they are good enough for a lot of stuff with 7 GB of RAMs and 14 GB of disk, 2 cores, so kind of nice. If I go for all options, I can go big here and I can start to look some other where they have, I don't know, they have 28 GB of RAM, a much more bigger disk, or even I can even go to take a look at the bigger one, the GPU ones, where we are going to be able to get, I don't know, this one with 224 GB of RAMs and 672 GB of disk. You may or may not need this. I don't know. For my test, for my labs is good enough. Main data here, main important thing to consider here is that you are going to pay $4, $6 in the big ones per hour. For me, usually this one is good enough. The NC6, which has kind of more than 50 GB of RAM, almost 400 GB of disk, and it's good enough if you manage to turn this on and off. This is the one that you're probably going to use. And with the free trial of Azure, this will give you enough time to play around. So my suggestion is probably go for this one or switch to the previous one. But as I mentioned, this is the place that we are going to define what type of compute we want to use. So I can go here, finish my tutorial. It's super easy, ABC, define a type, put a name, and depending on how we're going to use this is going to automatically create new node if I need. It's going to scale up or down. This is the tailored info for this, but I can create my compute cluster here. The other element that I'm probably going to use a lot here when I am doing machine learning is, I am going to work with data. Data is kind of a key part here. So I can go here and create my data sets and create connect here. I can create a new data set from a local file, from a data store, from web files. I can do plenty of stuff, and it's super easy. So in example, if I want to import here to train, to do this sentiment analysis, I can go here and say, I don't know, I have one which was tweet, min tweets. Let me see, it's somewhere here. Yes, tweets. Let me open this with Notepad++. So I have here 1,000 rows flat file, which has basically a label and a tweet. I can't remember where I found this. I will share the resources at the end, but it has tweets, and they are labeled if they are mean or not, basically toxic or not toxic tweets. So you have here a 4 or a 0, and then you have here the set of tweets. If I want to import this file, I basically go here, I'm sorry, mean tweets, put a name. This is not a tabular, this is a single file. Let's import this. I will upload the file. Mean tweets, there it is. It's going to upload the file, and then I'm going to be able to have, oh, sorry. It's a tabular one. There it is. And then I'm going to have some information here, extra info to define. In example, if I have here my first row is a header or not, I can skip rows from the first line for all files. So I have a couple of very simple options, very simple parameters that I can work here. But hey, this is my file. This is what I have here. I have a label. I have a tweet. So it's kind of good enough. And then I can start to use it. So this just has 2 columns. If I import a bigger file with more columns and I don't need the other ones, I can enable or disable the files. I will leave it here. And also, this is a very simple process, but it's smart enough to understand that the data in these columns are numbers, so it's integers, and the data here is a simple string text. We are not dealing with very complex type of data here, just a string, Boolean, integer, the basic, the ABCs. But again, this is good enough to cover several scenarios. So once I have this, once I have imported this, what I can start to do, I can start to use, I will have my file here, I can start to use kind of the options and the tools that I have here in Machine Learning Studio. There are a lot of assets and stuff that we want to do. I am going to go fast for the main 2, which is basically compute, the compute that you're going to use, and also the data sets. Remember that data sets, I imported a text file, but I can connect these with my data store, with my data lake. It could be much more complex if we need. But what can we create here? We can create notebooks, and notebooks, you probably know them. This is the ABC of most data scientists. We work in Python, we work in R in notebooks all the time. So I will leave notebooks because you're probably going to see this a lot. And there are 2 main elements here. We can create experiments using a visual designer, and the designer is super simple. It's something that will allow us to create and to train machine learning models without writing code. I mean, we may want to write small lines of code to do some task, but it will probably cover the rest of the actions here. And we have a set here. We have a full data set of assets that we can use to work with the data, to sort data, to clean up data. We have a lot of machine learning algorithms also here that we can use here. So, and at the end, this is a canvas, I'm sorry, where we are going to drag and drop elements, and we are going to create our model. So let's create one from scratch, very fast, very simple, based on the sentiment analysis. Again, sentiment analysis is kind of the hello world for this. So let's put sentiment analysis for tweets. So this is my canvas. I'm sorry, ugliest nightmare. Sentiment analysis for tweets. This is my canvas, blank canvas. We start with data sets. We have here the 4 data sets that we defined before. I have here my mean tweets created a couple of minutes ago, and nothing fancy, just drag and drop. I can even go here, right click, and visualize the data. I will do a preview, very simple preview of the data that I have here. This is small, 1,000 rows, 2 columns, so very easy. If I have more columns, I will also have some histographic information around the stuff that I have here. For us, it's good enough. So the next step in our slides was, hey, we need to do some feature hashing. We need to convert one of the columns to text. So I'm going to go here. I don't know where it is. I can remember, but I know that I have feature hashing here. So I will drag here my column to see what we can do, what we need to do. And the cool thing here is that every module that I need to use here, everything that I want to have, if I am not sure here how it works, I have a fast link to the documentation where we can go here and start to see how to use this and how we need this and what is feature hashing. So for me, it's also a great way. Sometimes I am just following a tutorial. I am not sure what I am doing. This is a great way to also try to understand, okay, what is this? I see this all around. I know that I need to do this, but I don't understand the deep insights here. You may want to spend here a couple of minutes try to reading this. What is this feature hashing example, and then you can use it. For me, it's going to be very simple. I am going to connect here the data set with feature hashing, and I am going to say, okay, I need to apply this text featureizing to a column. Let's select the column, and the column will be, can't remember the name. Let's wait a second. Sentiment tweet text. This is the one that we want to do, and that's it. I already applied this. So the next step that I usually do here, and remember, this is very simple. You can do this much more. The professionals are going to do a lot of stuff here before moving forward, but the next step here for me is usually I have my data, I already clean my data, do some stuff here, in example, the feature hashing, and then I need to split my data. I am going to split the data to have 70-30 or 80-20 to train the model and to evaluate the model. So again, I go here, I go for split, I will have a couple of split assets, and cool topic here, I have two assets here to split data, one that is going to split kind of regular data that we have in tables or in a flat file like this one. But if we are working with images and images are working and organized with some kind of folder structure, we also have one specific to split images, so we can use these images later for training something different. For us here is just going here, I'm going to split the data, I am going to use 70-30, and that's basically it. I am going to have two outputs here with my big set of data for training and a smaller one for evaluating. So once I have this, I am going to train my model. And this is the only part when we are going to do this that it's not very straightforward, because this is how it works. You need to train your model, you need to connect one of your input data to train the model, but then you need to pick up an algorithm. This is the part that you are going to define, okay, what I need to do. The first time that you use this is not super clear how to do this, but this is how we need to pick up our algorithm. So I am going to go for the two-class boosted decision tree. This is one algorithm. Again, if I want to know more, I can go here, learn more, and see how it works, how to configure this, which are the parameters that we are going to use. Tons of info here how to use it, but I am going to train my model using these two. So that's basically it. And I have here my train model, and I need to define the label. This is a regression task, so I need to do some kind of a prediction, and I'm going to predict what I want to predict, the sentiment label. So that's it. I am almost there. I already have my, 90% of this, it's done. So what I need to do now, I need to score my model. I need to evaluate. I did the split. So we know we are going to use some data for train the model, and we're going to use the rest for a score. So I'm going to connect my trained model here, and I'm going to connect the rest of the data with my score model, and then I can score my model. I have a lot of settings here, how to do the score. If I want to do some specific stuff, I am not going to get deep here because this will require some extra 40 minutes of how you're going to run this. But once I have this, I can evaluate my model, and I can basically finish this. Evaluate model, connect here at the end with this, and it fits, yes. And that's basically it. That's my model ready to use. It's going to pick up the first set of these 1,000 tweets that I have here labeled with toxic, mean or non-mean tweet, and then it's going to convert the tweet, do some hashing in the tweets, then it's going to split the data, it's going to train the model using this algorithm, and then we are going to evaluate the model to see how it works. The only extra step here that I need to do is I need to define which compute target I want to use. So I only have one here created, this one. I am going to select, and then I can submit this to train. So I am going to create a new one. Let's do this mean tweet sentiment, mean tweets prediction. And that's it. I created the model. It's working, yes. It's preparing the run. It's going to do a lot of stuff in the back. But the cool thing, the amazing stuff that we can do here right now is that once the model is trained, I can quickly convert and create the model to be used as an HTTP endpoint. So I don't need to do anything else on top of this to start to use this. I can even go and download the model if I want, a PK file to use locally, but if I want to use this trained model in the cloud, I can basically, let's see if it finished fast, I hope so. Let's see how we can click, and have an endpoint where we're going to do this. As you probably see here, a couple of the boxes are changing. It's starting to be queued, starting to prepare this. Usually takes, if I don't have anything running, usually takes between 3 to 5 minutes, so we come back later here. But I want to show you, I went fast for this because I want to show you this is a different way to create an Azure machine learning model. I'm sorry, to create a machine learning model. You don't need to code here. Sometimes for some operations, you have a Python script that you can put somewhere here. Oh, it's running, I'm sorry. But you can add this as an extra step. So you are going to have an input, a Python script with an input and output. And if you need to do some, I don't know, whatever crazy data filtering or something like this, you can use Python to do this. Pandas is amazing. They have already imported most of the popular libraries that you're probably going to use. Pandas is there, NumPy is there. Everything popular is probably there. So sometimes you need to do something very specific. You can use Python. You can use also R. R is going to be hard to get here. Well, show 20 more, but it is the same with R without data. R script, there it is. So you can also run, if you are more familiar with R, you can also run R script. But there are plenty of assets that will probably help you. So an example, if you need to do some data transformation, you can add columns. You can apply math operations here to collect the columns. You can clean Mrs. data. You can define some rules that if some row has some, I don't know, empty rules. Hey, clean this row. Do not use this row. So it's very visual. And again, it will probably help you to cover a lot of scenarios. And the nice, for me, the very good part is that there are plenty of samples. So if you want to do something like I just did, test classification, do not use mine. Remember, crappy demos, not use my code in production, go for the real one. But hey, you can pick up this one. This is also using a Wikipedia data set, and this make a little more complex and much more powerful set. But hey, you can start here, copy and paste this, and work with your data to see how it works. So I really think it's a great way to do something different because it's visual, it's very easy to understand what is happening, and it's a great tool. I will move forward to the next scenario, which is basically the next tool, which is basically to come here. Again, another disclaimer. Do not use my code. Do not use my sample. Copy the good ones. Go for Microsoft documentation. This is what we have. But let's use AutoML. AutoML is kind of the third part that we have here in Azure Machine Learning, which is basically let's do machine learning without even think of algorithm, data cleaning, or whatever. And I like this example. I use this example when I talk about machine learning.net. of how to do this. So an example, if I want to make, I have a data set with taxi trips, Uber trips, and I know how many people drive in a car, I know the distance of a car, the minutes and the fare, and I want to create a model to predict how much a taxi trip is going to cost from A to B. So what we have usually here, I have features like distance, trip time, car type, whatever. I have algorithm. This is the nice part. I have the gradient booster, nether, the SGD, LGBM, plenty of algorithm, and each one of these algorithms has some kind of customization, some kind of parameters. So what I am going to do here, I'm going to make a test to make my first prediction, picking up these features, picking up an algorithm. Then I am going to pick up a couple of parameters with some values. And after adjust this and train my model, I'm going to have a model which is 30% accurate. Okay, that's fine. Let's try something else. I pick up different features with a different algorithm, with a net suite of parameters, and I have 50%. And I start to do this process 1 time, 2 times, 3 times. I start to do this again and again and again. And then, and this is just a simulation until at the end of 15 tests, my best model is this one with 95% of accuracy, so I will use it. That's fine, but it takes a lot of time because you need to understand how to do this. So AutoML is a tool, is part of Azure ML, where we are going to basically leave Azure Machine Learning to do all of this testing of different models and different parameters to see how it works. So we are going to define the input data. We are going to define our goals, what we want to do, a regression, a classification, or something like this. Apply some constraints. So I don't want to run this for more than 2 days, or there are a couple of constraints there. And AutoML is going to start to do the magic. It's going to start to create the model, it's going to start to play around with different algorithms until we get the best model. And when we are here, we are going to have also some detail, some information about, hey, in example, these top two models, A and B, this is how these columns, how these parameters impacted on getting here. So an example, in the first model, model A, the distance and time of the day were very were very important. And in the second one, the trip time was more important. So it will help me understand that maybe at the end, what I need to do is A, B, or C. So how we do this? Not the drone, not the drone. The drone is for the end. So how we do this? Go to, again, Azure Machine Learning. We have here a designer. We are going to the home, and we go to Automated ML. I have a couple of these projects. I'm going to show you the outputs later. But let's create a new one. And as usual, ABC, data, training, and use it. So I'm going to select my data set. I'm going to select mean tweets, the one that we already seen, sentiment analysis, hello world. And then I am going to, once I have my tweets, I am going to define a couple of constraints. Okay, what I want to do, let's create a new one. Let's put mean tweets AutoML. What I want to predict, I want to predict the label. So what I want to use as a compute cluster, again, I define a compute. This is the one that I'm going to use again and again. And that's basically it. The only thing that I need to do here at the end is what I want to do with my data. Because this is a very simple model and we have a number and a text, it automatically selects regression. But we can do forecastings from time series, or we can even do classification. If you have a more complex model, we have a model where we have some, I don't know, we have some text, and this text is kind of a category. We can do this prediction for classification. There are optional configurations here that we can use, like an example, which is the metric that we are going to use to evaluate which is the best model. Here, what AutoML is going to do is going to run a different type of algorithm with my data set. And at the end, we are going to have a kind of a list of algorithm 1, this is the value, algorithm 2, this is the best value, algorithm 3 is the best value, and it's going to suggest us the best running one is the algorithm 3. And so we need to define which is the primary metric here. As usual, we need to want more. We need to understand which is the best metric to use in the type of activity that we want to use, classification, regression, non-time series. This is the place that we can start to read and understand which is the best one, which is how each one of these work. I usually, for example, for regression, the root mean square error is good enough for me. So this is the one that I have. And I also like to check this explain, because this is the part when it selects a best model, we can get some insights why this model is better than the other. Then this is a simple one, but if we have a big data set with a lot of columns, and I don't need all of the columns, this is the place that I am going to enable or disable the columns. So an example, just to show you, let me pick up a different data set. This is a big one with a lot of columns. So this is AutoML, yes. That's a column label, sorry. So here, this other label has a lot of different columns, but I only want to predict the label, and I don't need to use the revision, the year, or whatever, but I can also go here and say that, hey, use this with the median for this or that one. So there are a couple of options that we can apply in AutoML, but we don't need to do anything else. We don't need to change a lot of stuff. So let me go back here, go back to our mean tweets, like our mean tweets data set, next, regression, everything is fine. So this will create a new automated ML run. So it's going to run in the back, it's going to have some, it's going to start to try to test a couple of different models, and it's going to suggest me how to use the best model. And again, for me, the cool thing about Azure Machine Learning is that once the model is run, once the model is trained and is available here, I can easily get here and create an endpoint and publish this to be used from everywhere. So I have all of the tools that I need to train and use in a single place. So let me go back here. It should be running, not started. Let me see what is running right now. Go here. So I have 5 runnings. So let's take a look at one of these. So I run one early in the morning, so you can take a look at what is happening. This is using a big data set, and I was expected this to run for a couple of hours, but I want to show you how it works. So this is, again, this is using the 40,000 rows of Wikipedia with all of the features to do prediction of the comments. And the cool thing that we can see here is that I can start to see the models. So this has been running for a couple of hours and already test different type of algorithm here, like GBM, XGBoost regressor, ElasticNet, decision tree, ElasticNet, with a different set of parameters here. I have some values here. So right now, the best one will be this one with 0.18 with lower numbers, better model, but it's running. It's going to give me the information. And at any moment, what I can do, I mean, I can download the model. If I want to have the file of the model, the PK, I can, I can download the model. So it's going to generate the PKL, I'm sorry. It's going to generate the file, and I can download it to be used. If I want to use my model locally in my Python script or whatever, I am going to use this. Let's give this a second to, oh my God, it's going to be a big model. So we can take a look at this, but I also want to show you how you can, how we can understand this. So it's going to download the model. Come on, Edge, download my model. There it is. Save as, download. There it is, my model, big zip file. I have it there, but I can go here and go for an explanation. Oh, it's going to try to analyze. Okay, perfect. It's going to, in the child runs, I need to explain, I need to wait a couple of minutes. Sorry, I think I already have this done. It's probably I didn't finish click, but I can go here and get some more details about how it's happened. But the idea is that this run has a lot of child runs that are related, and basically are the ones who are testing different type of models, different type of algorithm to get the best one. So at the end, what we are going to have here is this running process, and we are going to get which is the best one. I don't need to remember here. I don't need to start to figure out which is the best combination of model and parameters and algorithm. I'm sorry, algorithm parameters to get this. AutoML is going to do this. It's going to take some time, but it's going to give me the best one. If I go here to AutoML and take a look at one of the finished one, let me run. Let's see all experiments. The CTS should be run. Yes, there it is. So in example, this one, the best model was using, it's a different scenario, but for the toxic data, very similar. This one is the one that was the best one. And I can take a look at the other metrics where I can see everything that was analyzed here in this model. And I can even take a look again. And all of the trained, this is all of the different algorithms with parameters that AutoML trained to solve my problem. And in the best one, I also have the explanation of what is happening here, what you can do. So I think I deleted the data. Oh, I don't have everything here. So sorry. I deleted the data set, cleaning this for this, so I don't have any sensitive data. Sorry, I missed this one. But keep on this. It's going to analyze, it's going to use different algorithms, it's going to suggest to the best algorithm. You're going to have some information about the best one, why is it, and you can use it or not. And the important part here is that in the output of logs, you will have access to everything that's happening in the back. If you want to understand how this happened, you can get here and start to read the Python code that generates and tests and do everything. So you can do everything here. You can start to read the logs of what's happening, how it works. Everything is here. And as far as I understand, somewhere here, it's also the PKL. So here we have the model. I can even download the model from here. So everything is here to go deep. But going back at the beginning, if I want to do an AutoML run, I only need to select my data, select a column, target column, the label, select a compute, and click, 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 and it will do everything that I need kind of for free. I don't need to go deep and get any more details here. So I was aiming, and I'm sorry, I know that I went too fast, but I was trying to have the last 10 minutes for Q&As. As you can see here, I have several models and experiments running in AutoML. The idea is that at any moment I can go here to my designer, to the sentiment analysis for tweets. It's still running, so it completes a couple of tasks, but it's going to still run for a couple of more minutes, and maybe at the end we can see how it works. But I want to give this last 10 minutes for Q&As. I hope that I know it was fast, sorry about that, but it will give you a sense of what you can do here with Azure ML. It's an amazing resource, and I will also invite you, if you want to do more, feel free to do. I like this one. I am sharing this in the Q&A, in the IM code, a couple of tutorials. So, an example, you can do some designer and the same with AutoML. Let me pass the AutoML, and I will read the question that we have here to see what we have. So, human, sorry if I get your name bad pronounced. My English is not very good, so sorry about that. But human asked about how to update the dataset with new entries. Do we have to swap it or new manually? So the dataset has a cool feature here, an amazing feature that you can create new versions of the dataset. So I have them into it. It's going to be the same, but I can create version 2. Again, tabular, same here. I will upload the same file just to it here. So it's going to be the same file, and I can create different versions. And usually when I have the versions, let's wait a second until it's loaded here. First file has headers, come on. So once I have here, and it's going to be it's going to work. I will have here my data set with 2 versions right now. Sorry. I'm going to have current version 2, and I can run my experiment again, and I can, it will automatically pick up the latest version. I can remember here, there is a way, I never done this visually. I always do this with the script, but you can also go here and go back to a previous version. So if you have version 1, 2, 3, 4, and you're using 4, but somehow you need to roll back to 3, I can't remember how to do this. I have a script somewhere here. It's not part of the documentation how to roll back a version. So this is a good way to do this, and your data set is going to be here. All the time, latest version will be the last one. The main advice here, the main constraint here is that do not kill your schema. Do not try to keep at least the same column names, the same data that you have at the beginning, because if you change a lot of things, you are going to trigger a lot of different errors around. But this is, again, this is the idea for this, is to try to have a centralized place to work with data, and this is one way that you can have and update new data with new versions. Any other questions? Anything else that I missed? Again, I know that I went super fast, but I want to give you a sense that you can do, and there are plenty of tutorials and stuff that you can do around Azure machine learning, so you can test it and hey, maybe solve a super fast problem just using AutoML. And hey, you're going to save a lot of time and a lot of. For me, AutoML is a cool way also to learn how to do this. What is happening in the background? Sorry.
Hi, Bruno. So one of the things is that we have sent all the credits to all the participants, Azure credits, so you can go and solve a really quick problem on automated ML and designer. Along with that, some of the participants have texted me, how about the image and video classification? Like, can we do them on automated ML and design as well? Like, do they have pre-trained models on that?
Yeah, so in example, I think the first one, yes, the first one. Designer has a couple of samples that you can take a look around to do image analysis. So this is image classification with DenseNet. DenseNet is a popular model to do image analysis. Basically, what we are doing here is transfer learning. We are going to pick up our own set of images. In this case, it's going to be animal images, and then we are going to use this for train. But yes, this is an example of what you can use and follow the steps that are here. So start with the image data set. If we take a look at the image data set, we don't have a visualization because this is not data. This is a folder with images here, but we can take a look at this and then start to see next step. It's going to convert to image directory. It's going to do a split. Remember that when we talk about a split, there is a split for data, standard data, numbers and text, and a split of files. This is a file split with images. And then we have here a couple of outputs of how to do this. And at the end, we have the DenseNet model. There are different versions, so you can play around with different versions. So they have different layers. This is a deep learning model. And then it's going to train using PyTorch, because this is what we use to train this. But hey, this is one that you can use to do some image classification. AutoML right now, it doesn't support any image scenarios. Right now it's regression, time series, and oh, I forgot the last one. Into it. So sorry. Emergent series and classification. Yes, classification. Oh my God, I'm supposed to know this. Let's pick everything, compute like this. So this is the 3 scenarios: classification, regression, and time series forecasting. So this is what is supported right now, no AutoML. There are other ways that you can do AutoML for image. I would probably, if you want to really do image without coding, you can go to custom vision.ea, part of the Azure Cognitive Services, and it's the ABC of image classification. You can upload images. Let me show you a trained model here. You can upload images, you can tag or label your images, and then you can train a model. So I have this super crappy model that has 3 tags with humans, flowers, and fish. And I can go here, open, where is Paint? Where is Paint? There it is. Open Paint, draw, and I'm so sorry. It's probably not good at any moment. See how I draw an amazing fish, and let me, I don't know, I will pick up one of the names, Ankita. So you can see that this is our one, and also drawing with the mouse is not my best skill, but hey, this is a fish. I can save this like in my desktop. And once I have my model trained, I have trained this model, upload images, tag and train, I can test this. And the way to test this, let's upload the one that I just created. This is sample data. Let's upload this, and it will analyze. And hey, you know what? It's a fish. 99% sure that this is a fish. I will use, if you need to do object detection and you want to avoid everything happening in the back, you want to avoid coding, customvision.ea is one of the coolest entry points to do this. And by the way, this one is labeling images in kind of a label and image. When you create a new project, you can have much more complex projects, like in example, this one, when I train a model. Oh, this is not the latest one. I think this one. This one, I train a model using an image to detect parking spots and cars. So in example here, you can, this is an object detection. You can select something here and then add your tag. What I have here is I select some spots and I said, this is a parking lot, spot 1, spot 2, spot 3. So in this one, if you do the analysis, if you do the, to train a model and you do the analysis, you are not only, you are going for the output, you are going to have, hey, I analyzed this image and I found this spot here in this region. I was going to give you the coordinates, maybe spot 4, and you're going to have a confidence. So I am 25% sure that this is spot 4 here and a spot 3 here. Let me, I don't know if I have it. Let's go for iteration, quick test. I should have some test images for this one, machine learning, parking lot, test. For an example, if I submit this photo, it's going to say, hey, 100% sure that the top is the label, garage B, 96% sure that this is spot 1, and 91% sure that this is spot 3. If I lower the threshold to 1% and I submit again, let's submit another photo, still 100%, 91 and 96. I think I pick up the same photo. Let me pick another one. So the model was trained very good and it works. If I go to the first iteration, which was a crappy one, and I select the same file, it's a mess. My first iteration for this was a mess. I trained it more. So well, it seems to work. But if I clear the threshold here, if I made everything just show me everything bigger than 50%, I have here some output here. But take a look at computer as the customvision.ea. Let me paste the name here. Oh. Vision.ea. This is the URL, and it's super useful if you want to do something image related and you want to avoid coding. And by the way, the final topic here, if you want to use it, you can even export this as a TensorFlow model, as a Docker file. So once you train your model here in a visual way, you can export and use it. And sorry about this. This is not this is not Azure machine learning, but it's a useful tool if you want to do things fast for image in the image scenarios.
Thank you so much.
So, any other questions? Okay, I will leave this. I will leave the.
Hello?
Yes, sorry.
Yeah. So I was asking that what you did with the code, it took like 4-5 minutes, you said, right? So how much does it take for a usual ML program to run? Like the one you make, the prototype, you call it, right?
Yes. So depending, it will depend on a couple of things. First, which compute resource you selected. If you have a small resource, compute resource is going to take a long time. If you have a bigger, it's going to take less time, but you need to pay more. So that's one of the important things to have in mind. The second is how much data are you using? If you are using, I mean, right now, the stuff that we are doing, it's, the stuff that I was showing was very simple. These files that I use are 70K, so they are small files, but they're still queued there. And the first one, which is basically slowing everything else, it's a 17 megabytes text file with the Wikipedia annotated data. So it's going to run for a couple of hours, at least using this compute, the standard one that I have here, the NC6, and a 10 megabyte file is going to run for an hour for sure. I was sure that it's going to be an hour, so I triggered this 1 hour before we start. So we have one output, and it's running for at least 2 hours for me. So keep 60 minutes as the minimum, but keep in mind that it will be probably longer, depending on how we use this. By the way, my computes are not dedicated. So when I create a compute here, when you create a compute cluster, one of the options are dedicated or low priority. I have always low priority because I don't want, basically because this is testing mostly for me. So when you put low priority, Azure will give everything else, everything other task that is around is going to give priority. If you go for dedicated, it should be faster. But the ones that I have is running low, is running slow because I also have this feature here.
Okay, all right.
Okay, and as I mentioned, if you have any questions or anything else, fastest way to contact me is in Twitter. This is the place that I probably answer faster. I know that your colleagues know that I am faster in Twitter than in email. So sorry about that. But if you add me and DM me or whatever, I will probably take a look here and answer. And I'm happy to help in anything else. Happy to help if you need anything else. Okay, I think that's it. And I don't know, do I miss any other questions?
I'll just check the chat real quick. So we really don't have anything on chats. So if anyone has any more questions, they can just, speak up.
Hey, no problem. As I mentioned, I will be around online for a couple of hours here. So if you have any other question, feel free to text me. Otherwise, it was a pleasure. Good luck with the stuff that you are doing today. I hope you have an amazing weekend. And hey, see you around. Goodbye.
Thank you, sir. Thank you for addressing us. Um, So now we will be ending our today's event. Thank you to our speakers of the evening, Siddharth sir and Bruno sir, for joining us and enlightening us. I would also like to thank Nala ma'am for joining us, and thanks to all the patient listeners. And also we have sent Azure activation codes to the attendees. Please check your emails, and I hope you all had a great learning and understanding.
We also have floated your feedback forms on the chats. We'll also put them a link from them in Discord server for us to have a better organizing session. We again thank all the listeners and all the participants who enjoyed this. Hope you enjoyed this as much as we did.
So it really was a great session.
Really, thank you to Sarthak, and really thank you to Bruno, and thank you to Narina ma'am for coming on. And thank you to all. Good luck, everybody. Stay vaccinated, stay home, stay safe. So we'll be closing down the event here. Thank you so much. We'll see a lot of you tomorrow as well at Accessathon. So here is to another great weekend. Bye.
Bye bye. It was a nice event.
Bye, Dee.
Bye.